Hello everyone, and today we're going to talk about window creation inside of our game engine, and I'm really excited to share this with you because that's the first time we actually will create an interface in this series. So what I mean by interface, as far as you know, we will create our game engine to be a cross-platform application, and we want to support like Linux, macOS, Windows, and all this stuff. So our window is actually the first thing that should be a cross-platform, because creating a window on Windows is like one kind of API, on Linux is just another API, and all of this stuff. So we should create an abstract layer, like layer of abstraction that will tell like, okay, so there is like function resize window, and this function will take a width and height of a window, and it will resize our window. So we doesn't care about how this actually implemented, because it depends on the platform we are currently on. So on Windows there is like one function, on Linux there is like another function, all this stuff. So our Raccoon will actually have a window class that will be just an interface. Like it will contain all of this function like resize, set height, set width, maybe like get title, set title, and so stuff. So but the realization will depend on platforms that we are currently are. So to define a platform, like how to detect on which platform we are. So to do this in your C++, we have like a macro. So if you are on Windows, there is like two kind of windows. There is like 32-bit window and 64-bit window. And if you're on 32-bit Windows, then there is like Win32 defined for you. And if you're on 64-bit Windows, there is like Win32 and Win64 defined for you. And the same stuff for Linux. There is like Linux macro, and there is like macOS macro for Mac. And we will actually create our macros like Raccoon platform window or all of this stuff based on these macros. So for this we will create some kind of platform detection code, and we will actually use this platform detection inside of a PCH. For those of you who don't know what is a PCH, it's like a precompiled header that will be compiled before everyone else, and this will be included inside of every single source file that we have. So CMake actually did this for us, and let me just show you how to do this. So there's a lot of changes as you can see, but we're currently interested only in this guy. So we have a PCH file. This PCH includes just platform detection. This PCH will actually be compiled into binary code, and it's better because the size of this PCH will be like more than just include this, but it will be linked faster and all this stuff. So our PCH actually has just only platform detection, and only platform detection only should be included by a PCH. So we define Raccoon platform windows only if we are on Windows 64. So we currently doesn't support 32 window. I don't know why. I just don't want to support this because it's old. Also, if we are on Linux, we define Raccoon platform Linux, and if you are on Apple, so we define a macOS. But currently I print some errors if you are on Linux in macOS, because I don't have a Linux and macOS to test whether this are perfectly compiled and everything works properly. So just for now I said that this is like an error. So yeah, in future I will test this and I will change this. And also based on our platform windows, we define what kind of realization we will use for our window. So let's just talk about it. So we have like two kind of realization for our windows. There is like Win32 for window, and there is like GLFW for everything else. For those of you who know what is GLFW, it's already an abstraction. So it's already cross-platform stuff that can create a window for Windows, Linux, and all this stuff. And we can use GLFW for every platform that we want. But the reason why I don't want to use it is because I would like to show you guys a little bit more than just this. So yeah, we can do this, but it's really important stuff to create window, and really important stuff to understand all of this kind of abstraction layer and all of this stuff inside of game engine, because we will use it a lot. So currently we have like two realization, and Win32 will be used if we are on window. So if I'm on Windows, then we use Win32 for window creation, and if you're on Linux or macOS, we use GLFW. Okay, so let's just talk a little bit more about maybe entry point. Yeah, let's start with this. So first of all, we change this. So for our main is actually cross-platform, and it means that it will run for like Windows, Linux, it doesn't care. So it's like cross-platform main. But there is like specific main for Windows, and that's Win main. It takes a lot of parameters, and we just the same stuff. I just want to make like if I actually create Win32 Windows, and I would like to create the main for Windows, because honestly Windows will be our primarily, like we will focus primarily on Windows. So that's it, and also because of that our application will also depends on this macro. So if there is like Raccoon platform Windows, then we have like Win main friend, and if it's not, then just main. So that's it, and now let's go to our window class. So as far as you know, as I said before, we have this kind of interface, so that's all of this a pure virtual function instead of this static one, and instead of this virtual destructor. So we have this kind of function that we will define like inside of our GLFW window and Windows window, and how all of this actually works. So we have a create function that is like a constructor, but it's static, and it returns a pointer to our window, because like this is just an interface, we couldn't create it. So we could create a pointer to it, and we can create like GLFW and GLFW window or Windows window, and set them to be like a pointer to our base class. So we take a parameter, this is the properties, and I create a struct. I don't want to have like parameters like this in it, so that's like Win32 or DirectX way to do this. So these properties have a title, a width, and height, and also we have some kind of window count, because we support more than just one window creation. I'll show you how we do this. We'll talk about it later. So let's just go to our create window and see how does this work. So first of all, there is like window count. We increase this count if we create a window, and we decrease this when we like call a destructor. So if we are on Windows, then we use Win32 window and we create it. If we are on Raccoon and like GLFW window, so if we're on Linux or macOS, then there is like this macro defined, and we create a GLFW window. So we create a Windows window, and let's just go to it. So this window is actually inherited from our base window class. It takes the same properties, so we just have these properties here, so we just simply copy them, and we have implementation of all of these functions. So get title, resize, get width, get height, and all of this stuff. So we have them here. And okay, so let's just talk maybe about how windows work in Win32. Okay, so we have like a class for window. For every single window we have a class. We can have like one class per a lot of windows. So that's how per multiple windows. That's how we actually do this. So we firstly check if as window count equals to 1, it means that we are like fast windows that are created. Why 1? Because firstly we create this base class, we add this like window count, then we create our Windows window, and we actually and we actually are 1 if we are fast windows that are created. So we initialize window class, and what we do, we actually create the structure to initialize it, and if it's not initialized, like we register this class, and if it's not, then we like check this in a set and fail. And we actually did this just like it's static, and we initialize it only when we initialized our fast window. Also, if we, where is the destructor? So yeah, if we are the last window, it means that if window count is equal to 1 and we delete it, then we just simply unregister this class and destroy this window. That means that we are the last window that's like remaining. And also, if we initialize window class, we then initialize the window using this function create window experimental. This is like pretty simple function. You can actually search for all of these parameters inside of Microsoft documentation. It's really helpful stuff, and I will paste the link in the description below. The only one thing that I would like to mention is that we use this converter from vstring, like y string, to our base string, because we want to use string. We don't want to use like white string inside of our like base window, so that's really useless. But Win32 use white string. Also, there is like show window, yeah, and let's just talk a little bit more about events, because that's something that I would like to talk to you. So as you can see, we have two functions for events. And I have this to explain you how does this all work. So inside of like Win32 or GLFW, we have something like a Windows process events, like Windows process function, that actually take a window like this, and also it takes some parameter to specify what kind of event we actually have. And every single window has some kind of, I'm not sure about implementation of this thing, but I will abstract this a little bit, so that it has some containers that store every single event that this window has. And when we have like Windows process, we send this window, we send what kind of event, and every single window also like, okay, so we send this event, and we how inside of Win32 we have like translate messages, for example, and as you can see, we doesn't take any window to it, so this doesn't know about window at all. It's nothing. So how does this work? It actually takes every single window that like handle window, in our case in Win32, and it goes through every single window and see whether events of this window are currently, like if this window has some events or not. And if it has, then it goes to Windows process and it sends this event. And then how we will work, we will set, this is a user data, so every single window has a user data. What is a user data? It's just a pointer to something, and we will have inside of our window, we will have an event queue for every single window that we have, because we honestly need to have our events. And our events will be stored, like we will talk about it later, but just for now we will have user data. We will set this user data for every single window, and inside of this window process we will have a window, like handle window, and this handle window actually has a user data, so we will take a user data from it, and that can be a function that will actually take some kind of event of our game engine, for example a key pressed event. Yeah, so we will actually construct this key pressed event based on the parameters that this window process actually takes, and then paste this constructed object to our user data. So that's how all of this will work. But the actually difference why I specify this to be static and per once, because this actually updates events for every single window, and this will update events of our window, so our constructed window, as you can see, like events from this event queue. So that's it. That's how we have it. So you can actually do something like process events and translate messages and then do this, but it's not the best way. Like you can do, because there will be just no messages after the first time you did this in a frame, and yeah, there is nothing will be changed, but that's good. And this function is static, and we will actually create it, implement this inside of our Windows window, and inside of our GLFW window there is also implementation of this function. So we couldn't actually compile this and this together inside of our build. That's why we add in CMake, we also have this kind of if host system name is Windows, then okay, then we add to our Raccoon sources Windows sources, and if it's like host system name is Linux or oh sorry, it's not, it should be like macOS. I will change it later, but anyway. So that's it. That's how we do this. And talking about GLFW, that's really easier way to do everything, because it also takes into consideration this as window count, because we don't want to initialize our GLFW if we if we create a second window. So we just want to initialize it once, and then we create a native window using GLFW create a window, and if it's not created, then we fail to create window, so using our assets. Then inside of our shutdown, we actually destroy a window, and we actually, so that's just the same stuff. GLFW terminate is just the same stuff with a class, Win32 class. So that's it. That actually, oh okay, and pull event is actually a function that also do pretty much the same stuff that this guy. So it just goes through every single window and update events. I'm not exactly sure about how this works, but it just is like abstraction of how it works. So something like this, but it can be a little bit different in like implementation. So that's it. That's how we have everything. And let's just go to our application and try to use this. So we have like two functions, or two windows. So we have M window and M second window. So we create a first window with default parameters, and we create a second window with a title second window and a little bit different size. So also we need to delete them, because now we create this using new, so maybe in future we will use some kind of a shared pointer, something like that. We will talk about it later, but just for now it's just simple delete and stuff like that. So inside of our running, we currently only process internal events, because we don't need to, we doesn't have any our events inside of our game engine, so we just don't need to do this. So we can just call it oncely, and this will update events for every single window that we have. So let's just see how all of this works. Let's just build for debug. So I think everything should be correctly defined, and also we will try to build the GLFW window, because GLFW is also supported on Windows. So I'll just show you that everything works fine on Windows at least, but I don't know how it will be, how it will work in Linux or macOS. So we have like two windows. As you can see, if I will, for example, click this guy, so it knows that this event will send to this window, not to this one. So we can do like this, guys. So we honestly, yeah, inside of Win32 we can close them, but inside of GLFW we somehow we need to actually process this close event and close them using destroy window, something like that, or close event, close window, and something like that. So yeah, let's just try to do this. Let's just go to our platform detection and just simply comment this and just define GLFW window. We know what we are doing. Maybe we are not. So we also need to add some kind of, okay, so we will actually add this manually. Okay, so that's pretty much everything we want to have. I think this should work. Yeah, I think everything should be okay, and everything should be good, and that's how we use like this abstract layer. So we just create a window. So our user will just create a window, and it doesn't care about how it's implemented on errors and stuff. So we just call some function and paste some parameter to it, and it did something, depends on our platform. So that's kind of abstraction that game engine actually gives to you. And if we hit a 5, we will see the same stuff. So, but just for now, GLFW doesn't actually process this event, close event, so we should actually close this manually, but we are done because we haven't create any events inside of our game engine. So that's it. We can just close the terminal and everything should be fine. So that's it. That's everything that I would like to show you. And the last thing I would like to talk about is Raccoon repository. So that's the repository that I create, and it has like 3 branches. You can actually read this. What is it? README. Okay, so I forgot about it. So you can actually read this README, and here is a lot of useful stuff. First of all is like how to contribute to Raccoon. You can actually contribute to like dev branch, and I really encourage you to do this because maybe I will also create a project, so I will paste here what kind of sync we want to create and add inside of Raccoon. So you all will know what to do, and also how to install, build, and all of the stuff that are here. And branches, we have main branch that will contain a codes that are completely tested and should be fine, and all the stuff. DAO is actually what kind of there will be like dev code, so it currently can be not tested 100%, but yeah, it's just DAO, and it's the branch that you should actually contribute to. And YouTube, that's our YouTube that we actually will have. So that's a branch that contains every single line of code that we create on YouTube. So that's it. And let's just maybe try to, okay, let's just add another git bash and try to add some kind of comments. So git add everything, because yeah, I forgot to type git status to see what I add, but anyway. So okay, git commit -m add window. Yeah, just add window, I don't know. It will be simple. So that's it. That's the end of this video. So don't forget to click the like button and hit like subscribe to this channel, and I will paste you some useful links in the comments below. And don't forget also to write some comments what you think about this format when I don't actually try to type everything and just show you what we did. So yeah, let me know in the comments below what you think about it, and goodbye, see you next time.